chemical reactions. So a chemical reaction is a change of one or more substances into other substances. And we describe chemical reactions with chemical equations. Okay. So for example, we have hydrogen gas reacting with oxygen gas to produce water in this case. Okay. And the coefficients out here kind of tell us how many of each compound we have on each side. So we have to have 2 of our hydrogen gas molecules, 1 oxygen gas molecule, and we end up with 2 water molecules. Now, balanced equations have the same number and type of element on each side. Okay, so if we look at this, we have 4 hydrogens on each side. You have 2 in the compound, or 2 in the molecule, times 2 molecules is 4. I have 2 oxygens on that side. And then on the other side, I have 2 times 4 hydrogens. So I have 4 hydrogens again. So 2 times 2. And I have 2 oxygens on the other side. Now, you balance chemical equations by adjusting the coefficients, which are the numbers out front, the big numbers in front of the compounds or the molecules. So what this ends up having then is the same amount of matter on both sides, which basically helps maintain our law of conservation of mass, which basically says that you cannot create or destroy matter. So the parts of a chemical reaction, again, this is a reaction for the oxidation of iron here. So the 4, the 3, and the 2 out front, those are all coefficients. And on the left side of the equation, we have our reactants. And on the right side of the equation, we have our products. And remember, what's happening here is when this is done, the reactants have become the products. And in a complete chemical reaction, there should be no reactants left when you're done, and you should have all product. Now, most reactions don't work that way. You have a little bit of reactants left, and there's different amounts of product produced depending on the situation and the conditions of the reaction and stuff. But in a perfect reaction, there would be no reactants left when it finished reacting, and it'd be completely products. But it's showing really reactants are what you start with, products are what you end up with. So water's role in this. So many chemical reactions occur in water. Okay, water does dissolve a lot of compounds because remember, water is polar, right? It has a positive and negative end, which a lot of other things are polar as well. So water is considered a universal solvent because it can dissolve so many different compounds. So this makes it easier for the substances to collide so reactions can occur. There's a model called the collision model, which basically says that for a reaction to happen, the 2 parts, 2 things reacting have to collide with each other. Well, water allows them to be mobile and collide with each other. Some elements and compounds actually react with water. So sodium, for example, if we put sodium metal in water, it will catch fire, possibly explode. Carbon dioxide will react with water and produce carbonic acid. Same with sulfur dioxide, except it produces sulfuric acid. So those are just a few examples. So for example, what happens here with the way water dissolves things is, if we have salt, for example, salt has sodium ions, which are positive, and chloride ions, which are negative. Well, remember, water has a positive end and a negative end. So the positive ends of the water molecule, which are the hydrogens, would be near the chloride. Okay, it's kind of what they're showing right here. You have the hydrogens that are all pointing towards the chloride because the chloride is negatively charged, the hydrogens are positively charged. So what will happen is the water molecules will come in and they'll surround a chloride ion and pick it off. And then other water molecules will come in and surround a sodium ion like this, and with the oxygens facing the sodium because they're negatively charged, and pick off that sodium, and then more water molecules come pick off the next chloride, etc. And that eventually breaks the salt crystal down into individual ions that are then surrounded by water molecules in the solution.